Hello everyone, welcome back to my channel Saisha Tech. This is Amogh Kaliwal. If you are new to my channel, please like, share, comment and subscribe my channel and press the bell icon for the latest updates. In the last video, we defined t-test. We understood different types of t-tests, when to use t-test, what are the steps included in hypothesis testing, and applications of t-test on example. In today's video, we will understand what is Ztest, when to use Ztest as compared to t-test, and few of the applications of Ztest. Ztest is a statistical test which helps us to determine whether the two population means are different when we know the variance and the sample size is large. The formula which we use to calculate the Z statistics is x bar minus mu divided by sigma upon root of n, where x bar represents the sample mean, mu represents population mean, sigma represents standard deviation of the population, n represents number of samples. The main difference between the t statistics or the t-test with Z-test is, in t-test we use sample standard deviation and Z-test we use population standard deviation. The n, the number of samples in test set is small, whereas the number of samples in Z-test is slightly large. This was the definition of Z-test. Now let us understand when to use Z-test as compared to t-test. When to use Z-test? When we know the population variance, we go ahead with Z-test. If the population variance is not known to us, but the sample size is large. Here, large means the sample size is greater than or equal to 30. Then we use Z-test. If both these conditions fail, then we go ahead with t-test. There are some of the assumptions which are made by t-test and Z-test. That is, t-test assumes standard deviation as unknown, whereas the Z-test assumes the standard deviation as known. As we have understood when to use Z-test, now let us understand what are the steps to conduct Z-test. There are 5 steps to conduct Z-test. In the step 1, we state the null and the alternative hypothesis. In step 2, we choose the alpha level, that is the certainty which we provide to the null hypothesis or the critical region. Identify the critical value of Z in the Z table. Then we calculate the Z statistics from the Z formula. And the last step is compare the test statistics to the critical Z value and make the decision whether to accept the null hypothesis or reject the null hypothesis. These were some of the steps to run Z-test. Let us apply these steps on examples. A principal of the school claims that the students in the school have an above average intelligence. When a sample of 30 randomly selected students was considered, the average IQ score was 112.5. Now we want to validate the claim of the principal. The population mean IQ score is 100 with a standard deviation of 15. With these parameters, let us start the testing of hypothesis using Ztest. The step 1 would be choosing the alternative hypothesis and null hypothesis. As the population mean IQ score is 100, which is a well-known fact, we will consider that as a null hypothesis, which is mu is equal to 100. The claim of the principle is the students have above average IQ score in the school, which would be our alternative hypothesis, mu greater than 100. In the step 2, we will choose the significance level, that is alpha, which is considered as 5%. In the step 3, we will extract the critical value, that is alpha for 5%, from the Z table. Let me share my screen and walk you through how to extract the value of Z from the Z table for the critical value of 5%. With the chosen 5% significance value, the acceptance region would be 1 minus 0.05, that is equal to 0.95. If we search the nearest value for 0.95 in the Z table, it is 0.9495. Hence, the Z value would be 1.6 plus 0.04, which is equal to 1.64. As we have understood that the critical value from the Z table for 5% significance would be 1.64, we will utilize this for comparison. In the step 4, we are going to substitute all the parameter values into the Ztest formula. So substituting the values of 112, which is the mean sample, 100, which is the population sample, 15, which is the standard deviation of the population, and 30, that is the number of samples, into the formula, we get Z value as 4.56. In the step 5, we are visualizing our problem. The mean population IQ score is 100 and the principal claim that the students in the school have above average IQ score. When we compare the values of Z from the evidence, which is 4.56, and the critical value which is considered is 1.64. The rejection region is towards the right, that is right-tailed test. Hence, the value of 4.56 is greater than 1.64, which validates that we can reject the null hypothesis. This gives us the information that the principal claim of the students having an above average IQ score in the school is validated. Now let us understand the second example of Ztest. The mean glucose level of patients is 100 with a standard deviation of 50. A recent research paper published provides us information that a cornstarch diet has a positive or negative effect on the glucose level. When we selected 30 patients randomly who are having a cornstarch diet, the mean glucose level was 140. Now we want to validate the hypothesis whether the cornstarch has a positive or a negative effect on mean glucose level. In the step 1, we are going to consider the null hypothesis and the alternative hypothesis. As suggested, the mean glucose level for the patients is 100, which would be our null hypothesis, mu is equal to 100. We want to verify or validate that the cornstarch has a positive or negative effect on mean glucose level, which means our mu would be not equal to 100 as our alternative hypothesis. In step 2, we are choosing the alpha value as 5%, which is the critical region. In step 3, we want to identify the Z value for the critical region. Now let us understand the pictorial representation of the problem. In pictorial representation, we are identifying it has a positive or a negative effect, which means it is a two-tailed test. Hence, we divide our alpha value by 2. Hence, we will observe or extract the alpha value for 2.5%. Let me share my screen and walk you through how to extract the alpha value for 2.5% significance value from the Z table. When we are considering 2.5% as the significance level on the two-tailed test, the acceptance probability would be 1 minus 0.025, which is equal to 0.975. If we search the value of 0.975 in the Z table, we can observe the Z value as 1.9 plus 0.6, that is 1.96 is the Z value for 2.5% significance value. As we observed from the Z table, the value for the significance of 2.5% is 1.96, which means the Z value or the evidence to accept the null hypothesis should be between minus 1.96 to plus 1.96. Above or below these values would be a rejection region. Now we are utilizing the Z-test formula x bar minus mu by sigma over root of n. Substituting the values into the Z-test formula, we get the value as 14.06. As discussed earlier, this value is exceeding above 1.96, which means we should reject the null hypothesis. This represents that the cornstarch has a positive or a negative effect on the blood glucose level. These were some of the concepts of Z-test. In the next video, let us understand some of the concepts of chi-square goodness of fit test. If you like my video, please like, share, comment and subscribe my channel and press the bell icon for the latest updates. Thank you.